Okay, so we're going to start conic sections. We're going to concentrate on 4 of them. Conic sections are formed by cutting 2 cones that are, they call it a double lapped cone, but basically it's right side up and upside down, and they meet at the point where you can see in this picture here. So depending on how you cut the cone, you can form circles, ellipses, which we used to call an oval in elementary school. We can form a parabola, which you are very familiar with, and we can also form what we call a hyperbola, which is going to look like a double parabola that goes in opposite directions. Okay, the angle in which you cut the cone with the plane is going to determine what kind of conic section you get. So if you cut the cone straight across like this at the top, you get a circle. If you cut it at an angle that is less than 90 degrees but greater than 0, you will get an ellipse. Now notice that the circle and the ellipse only cut one of the cones. Okay, this is kind of important. Okay, same thing for the parabola. You'll notice that the theta is equal to this angle alpha. So this line right here, let's put a little highlighter there. This line right here is called the generator. This line right here is called the central axis. Okay, if the plane cuts it at an angle parallel to the generator, then your theta is equal to that alpha. I know it's kind of hard to see, so you have a parabola. Now notice if you cut it like this, you're only going to hit one cone. Okay, now if we manage to hit 2 cones, okay, we form a parabola. So with this, it's actually really easier to look at the picture than think of the algebraic symbols of the angle. I like to look at the picture, but that's just me. Okay, so Edgenuity does something really kind of strange in this section. They don't spend a whole lot of time on circles to me, but they expect you to do a whole lot with them. So we're going to review what a circle is. Okay, a circle is the set of all points that are a given distance from the center, or we'll say a point called the center. So you've been looking at circles since like preschool. I mean, since you've been watching Sesame Street and things like that. So you're very familiar with the shape. So what we're going to do is we're going to kind of look at it another way. So I'm going to draw an XY axis here. Okay, and for the first circle that we're going to deal with, the center is going to be at 0, 0. Okay, so here's the center of my circle. Okay, now I want to build a circle with a radius of, let's say, 5. Okay, so from the center, I'm going to count out 5 units right, 5 units up, 5 units left, and then 5 units down. And then if I asked you the distance from each one, you would say, oh, it's 5 units away from the center. So the radius of my circle will eventually be 5. But that's not all of the points that are 5 units away from 0, 0. I can do other ones. I can do 3, 4. I can do 4, 3. can do the same kind of other points here. Do the negative, negative. Oops. Okay, so you can see as I build those circles up, or build those points up, I'm kind of getting closer and closer to a circle. Well, how do I know that those points are 5 units away from the center? Well, what I did, and I actually kind of cheated here, okay, if I draw a bunch of triangles that happen to be right triangles, and I know this isn't very neat. Okay, what I see is I see a bunch of right triangles that have a hypotenuse of 5. Okay, so if I take my points on the unit circle, I will get my radius of 5. But it happens to be squared. Okay, so I would have to take a square root. So now what I'm going to do is I'm going to go ahead and draw my circle. Okay, and you'll see I have an actual infinite number of points that make up a circle with radius 5. And all of those points will make a right triangle with a radius of 5. Okay, so the equation of a circle with center 0, 0 with the radius is actually based on Pythagoras. Okay, that's basically a rewrite of Pythagoras' theorem. You have your x coordinate and your y coordinate, which is your a and your b, and then your radius. Okay, now let's say that I wanted to move that circle around. Okay, let's say I wanted to give it a different center. Well, think about how we moved parabolas around. How do we move things around? How do we move it left, right, and up and down? So if I wanted to change the center from 0, 0, what I would do is I would rewrite my formula with my transformations. Okay, so the h controls the left and the right. A negative h will move h units right. A positive h will move h units left. Okay, and then for my k, a negative k will move k units right, and a positive k will move k units left. Okay, r squared. To find your radius, you're simply going to take the square root. Okay, so if I give you the equation, x plus 2 squared is equal to y minus 3 squared equals 4, okay, what you would tell me is my center is, okay, so that's a positive 2, so it's going to move 2 to the left, so that would be a negative 2. Then a negative 3, that would move 3, 2 up, okay, because remember it's opposite. Now this is the tricky bit, okay. At some point you're going to forget that that's r squared. Okay, so you need to take the square root and you get 2. Okay, now let's talk graphing. Okay, so if we were graphing on paper and pencil and not Desmos, what we would do is we would draw out our x and y axis, okay, just like that. I would graph my center, negative 2 up 3. So, and maybe put a C by it so you know. And then what I would do is I would count 2 up from the center, 2 down from the center, and left and right. Make it really easy. So up, down, oops, that's 3. Down, left, right. And then just very carefully connect the dots. Okay, and that's it. All right. So when you graph it on Desmos, you can actually type this in as is, and it'll give you a lovely looking circle. If you were given an equation or asked to find the equation given a graph, so let's do that. Let's go the other way. Let's say you were given this. Let's say you were given the center right here. Oopsie. There we go. And then there's your picture. So find your center. Okay, so my center is, let's see, 1, 2, 3, 4, and then 1, 2, 3, 4, 5. So my circle moved right 4, up 5. Okay, so when I put it into my equation, if I want to move right, remember it's negative. If I want to move up, remember it's negative. Okay, now to find the radius, you're basically got to count from your center. You can count left, right, up, down. Doesn't matter. I usually go right because I'm boring. 1, 2, 3, 4. Okay, now remember when you plug this in, this is 4 squared. So final form of the equation would be x minus 4 squared plus y minus 5 squared equals 16. And that's it. Okay, so circles are very straightforward. Okay, you'll see a lot of connections between Pythagoras and the distance formula. If you remember the distance formula, all of those things are connected. Okay, so in our next video, we're going to talk about parabolas. Now, Edgenuity spends a lot of time on parabolas. They actually spend about 2 sections on them. Okay, I think what's going to happen is you'll understand parabolas much better when you do a section that is dedicated to parabolas. Okay, all right. Thank you for watching.